Happy to see everybody here this morning to talk about tokenization, one of my favorite subjects and something that we're really excited about at Capital One, despite some of the twists and turns we've encountered on our journey here. So let me dive, well, first, the disclaimer. I think you guys have all seen these before. Let me dive right in. So we're a financial institution. You may have guessed that. We have hundreds of millions of customers, and we focus in particular on protecting our customers' data. So our customers, you've heard all the time in the field of cybersecurity, what are your crown jewels and what are you doing to protect them? Well, for us, our customers' data are our crown jewels. Of course, this crown isn't real. This is costume jewelry. It's $88.90 on Amazon. And so we're taking the same approach to protecting our data. We're using costume jewelry rather than real jewelry. If somebody steals the crown, they're stealing costume jewelry. Now, for us, that's tokenization. We're taking information like social security numbers and we're tokenizing it so that if an attacker steals it from the database in which it's resting, then they don't have anything worthwhile. I will tell you that I had purchased this $88.99 tiara on Amazon. I was going to wear it, and unfortunately it broke in my luggage on the way out, so you guys are really missing out. It was going to be a very dignified and regal presentation. So with that teaser, let me tell you a little bit about myself and Capital One. And I have been looking at the next slide rather than the current slide, so I'm sorry I was behind a little bit on those slides. But I'm Andy Osment. I've been at Capital One since 2020, where I'm the Chief Technology Risk Officer. In financial services, we have a model called the 3 lines of defense. If you're not in financial services, that's gobbledygook, but if you are, I'm the head of second line technology risk. In my career, I've worked in government. I was President Obama's deputy cyber czar, and at DHS, I led the cybersecurity portion of what is now CISA, back when we had a way worse name, so I'm very jealous of these CISA folks. Before joining Capital One, I was the CISO, the first line CISO at Goldman Sachs for about 4 years. Now, I'm a senior leader, and that means that I actually don't do work. Other people do work, and then I get to stand up on stage and talk about it as if it was me doing the work. So I want to take a moment and recognize the teams at Capital One who actually did the very, very hard work here. And those teams are listed at the bottom of the slide. And quickly on Capital One, I think our history is a little bit important and relevant here, so I want to give you just a touch. We were founded in 1994 by a person who thought, I can use data and technology to do credit better than any of the incumbents. And we've grown over time, but our founder is still our CEO, $40 billion in revenue, Fortune 106, and we've added products over time. But while we're still a young bank, a key thing for us is we hate legacy technology. And so, although we're 30-odd years old, we really work hard to minimize our legacy technology, which gets to something pretty critical for our work on tokenization, which is, in 2015, we made the strategic decision that the future was in the cloud and that being half in and half out was not a smart way to do it. That the right strategy was to go all in on the cloud, not try to live partially on-prem. And so we started our migration in 2015. We completed it in 2020 and shut down all of our data centers. We have a couple of colos left with a few things that we are not able to put in the cloud, but it's on the order of well under 1% of our applications. And think things like secrets managers where we have to have break glass physical access that are in those. So we're fully on the public cloud. That's been a massive accelerant for the work that we're talking about here. So let's talk in a little bit more detail about tokenization. So what are we tokenizing? Well, we have some obvious ones. In the US, the social security number. In other nations where we do business or hire employees, think the taxpayer ID, essentially. Obviously, credit card numbers, bank account numbers. Also, though, we have passport numbers, driver's license numbers, and we've tokenized those as well, and we're seeking to tokenize those as well. A data type that is always in the conversation, but we have decided so far not to tokenize, is date of birth. Because it just ends up having to be used in the clear enough that it just doesn't seem practical or useful. But honestly, we go back to that conversation a lot. So let me take a moment and define a term that I'm going to use, which is readable sensitive data. So we struggle with this because at first we said, well, we're going to tokenize the unencrypted data. But of course, it's actually all encrypted because it's stored at a minimum on, for example, an encrypted hard drive, or for us, really an encrypted S3 bucket on AWS. Also, a lot of the data is stored in a database where we have some type of database encryption, whether it is database level or column level encryption. But we're still viewing that as readable sensitive data because if, for example, you are a legitimate admin, you can access the database and see the data. And so the scenarios we worry about are a malicious insider. That's somewhat of a concern. But more importantly, if an adversary either takes over that admin's account or just takes over the application has to be able to see the unencrypted data, and therefore they can access the data. So we say that the data is readable even if it is encrypted at the storage level or the database level. If the application can access the data and just see it, then it's readable from our perspective. And of course, there's a lot of different ways that we could have solved this problem. And we don't solve it always with tokenization, but tokenization is our preferred solution. That's not true. Tokenization is our second preferred solution. Our first preferred solution is deletion. We love some deletion. And so whenever we find this data, the first thing we try to do is, can we just straight up delete it? And even for a bank that hates legacy, we have found plenty of data that was no longer actively used and could be deleted. So why did we decide on tokenization? Why don't we just use encryption? You can see some of the reasons on this slide. There's a number of benefits to tokenization, not the least of which is dramatically simplified key management. And key management has come a long way in the last 30 years, but it is still a pain. So it's helpful to have a solution where we don't have to focus on it. There's also no ability to compromise or brute force the key when you've tokenized the data. And more subtly, we can maintain format if we want to. So there are scenarios where we actually tokenize data, say a social security number, and keep it in the 3 numbers, a dash, 2 numbers, a dash, and then 4 numbers format. And we do that so that applications that don't need to see the untokenized data can still access and retrieve it and even show it on a screen without us having to change anything, even though the data is now tokenized. We can also embed checksums into the token or version numbers. So lots of benefits here for using tokens. So here's how we go about it. We're using, throughout this presentation, we'll use a social security number as an example, and we'll use a sort of garbled version of it that uses letters, just to make it more clear that it's tokenized. But again, we can preserve formatting if we want, so we could equally tokenize and have it be numbers in a traditional social security number format. So in this case, again, we're using the social security number example. The application receives the raw social security number. Maybe it's receiving it from a user, maybe it's being passed from another application, data store, you name it. The app then hands it off to a tokenization engine and requests a token, gets the token back, and then the application uses it for the transaction, it stores it in the database, you name it, but from that point onward, the application is handling a tokenized social security number. And of course, if it needs to access the untokenized version, it can send it back to the engine and request the untokenized number. I mentioned that that we can preserve format. So, in many applications, it's valuable for us to keep the format. It makes it easier to adopt tokenization. We have to change the application less. And so we do have that option. Now, there are lots of companies in financial services in particular that are doing tokenization, for example, at point of sale. If you're using Apple Pay or something, you're not really transmitting your credit card number when you make a payment, you're transmitting some form of a token. One of the things that we think makes this stand out is that we're doing this across our entire enterprise for all types of storage, anywhere we store data. And our process is straightforward and is captured in these 4 major buckets. So the first one, who would have known, is to take an inventory. Pretty much the first step of any security adoption or security lifecycle. And so we did do, for pre-existing apps, we did a manual inventory. I would have told you in advance that this would be the least valuable activity on the planet, that I would have no trust in a manual inventory, we wouldn't learn anything. And while I still have no trust in a manual inventory, we did in fact learn things. So I was surprised at how valuable that it was. For new applications, they go through a build readiness and a launch readiness gate. And so we find out about the information at that time and force them to build it the right way. So we've got both a front book and a back book process. But of course, I mentioned that I never believe a manual inventory. And so we want an automated version of validating that inventory. So we're scanning all of our data. Now, we started this process in late 2018. And we did a survey at the time of the tools available. Many great tools out there, but we felt that at the scale we were operating, we could do it more accurately and more cheaply with a tool tailored to our needs. And so we did, in fact, build our own tool. In part because we could focus on our use cases and really manage false positive rates. Now, we do still have quite high false positive rates, and that's intentional. We decided from the beginning that one of our principles would be to accept high false positives so that we never to dramatically reduce the likelihood of risk of missing a true positive. And so you can see here our false positive rates changing over time. Some of that is tuning, but it's also the case that we have different false positive rates depending on the data type we're looking for. So there are some countries where we have relatively small operations, just employees, no customers, and so we're looking for their taxpayer ID. We just don't have a ton of them in our data. And so our false positive rates for that type of data are going to be really high because there are just very few true positives to be found, so almost anything is going to be a false positive. I believe when I last checked for social security numbers, it was around the 30% level, our most common and sort of easier to find data type. Bank account numbers are hard. Bank account numbers can collide with SKUs, just like the number that you use for physical inventories can look like bank account numbers. For those of you not in financial services, bank account numbers have varying lengths and formats, so it's pretty painful to search for those. You can see as well that we had a hump in 2022. That's when we decided, all right, excuse me, it's time to focus a little bit on reducing false positives. Now, I mentioned, we're scanning our data, and I always feel like in cybersecurity, the risk is always in the asterisks. So I'm going to try to call out the asterisk in the footnotes in this presentation. Because when you're scanning data, of course, what is data? Often it's files, and we cannot interpret with our scanning tool every single file type in the world. We interpret rather a lot of them, but for example, our scanning tool is not going to find sensitive data in encrypted files, file level encryption, or audio files, or pictures. And as a bank, people do things like upload checks, right? Like we have pictures. And so that is an area that we still have a gap. So the next asterisk, what are we scanning? Key question. So we scan all S3 buckets. We also scan our data lake, which is built on S3 buckets. And we scan our Snowflake staging area, which is built on S3 buckets. Are you guys picking up a theme here? We're scanning S3 buckets. So what does that mean, right? Not all of our data is in S3 buckets. Well, first of all of our data should eventually land in an S3 bucket because all of our data should ultimately be routed to the data lake. And we have very high adoption of our data lake, so we actually feel pretty good about that. When we find a scan hit in our data lake, we trace it upstream and find the source of the data. So it almost certainly originated in likely a database used by an application that then after using it sort of sends a copy to the data lake. And so then we would go and remediate it in the database itself. So we think we've reduced a vast amount of risk and captured most of the use cases of sensitive data by scanning S3 buckets, but not all. So we do want to scan databases. We've looked at various tools that can allow us to scan databases. The problem with these is, in any large enterprise, you're going to have a variety of types of databases, and it's always just going to turn out that whatever tool you're using can't scan fully 100% of your databases. So what we've done instead is, after we evaluated a bunch of these tools, we said, you know what? We're just going to take a process where for every database, we're going to dump it to S3, do a one-time scan, remediate it, and move on. And so that's where we are right now. It is also an expensive process. This is one of those slides I had to spend a lot of time with the lawyers on. We decided we really couldn't share the volume of our data, but we can share the cost. And so hopefully I haven't left any clues that's going to allow anybody to figure out our volume. But you can see that by and large, our cost tracks our data. And it's currently $50,000 a petabyte. You can also see two interesting things on the data chart on the left. First of all, well, actually, on the data chart, the one interesting thing is we did a massive cleanup exercise in 2023, not tied to tokenization, just tied to, wow, our data is increasing rapidly. Do we really need all the data? Let's go through, find duplicates, find things that could be ephemeral or temporary, and make them temporary. So that helped enormously. The other thing you can see here is on the right, there's this big jump between 2020 and 2021. And some of that is the size of the data increasing, but some of that and then in 2022, it calmed down quite a bit. We did implement a lot of efficiencies in that 18-month window. One of them is we made the scan stateful, just so that we could skip things previously identified as false positives. Before, we weren't doing that, because our approach had really just been scan it once, find everything, fix it, only scan again where you had found hits that you remediated, and then you scan it again to make sure that you remediated them fully. But we're not continuously scanning all of our data. This is largely a scan once, scan the hotspots again to make sure you got it all, and then move on. Now, great, we're scanning stuff. Anybody has ever worked in security operations knows that scanning things is great, but what do you do when you find things? So dispositioning alerts is not at all a trivial part of this exercise. It is deeply important. So first of all, we put some effort into how we group the alerts. A finding is a single, for example, social security number. Most findings end up being a social security number is actually, we have a column in a database that is all social security numbers. And so you could have 10 million findings or 400 million findings. And you don't really want to report 400 million findings when you just have a single column in the database. That's a problem. You want to report the column. And so that is an alert. We alert on essentially the column rather than individual social security numbers. We then bundle those alerts into a case. So think about that as being all the relevant columns in the data set. We bundle cases into the data set. All the columns, all the different database tables. And then finally, we have a bucket. And a bucket is a person's accountability. And so a person has to deal with everything in their bucket, which is all of these different levels of aggregation you see on the left. None of the people here are accountable for buckets, or they'd be throwing things at me being like, this is a lot of work. It is really a lot of work to disposition and address these findings. But of course, that's where the value is for us, is to get this work done. So to do this at scale, we have SLAs. If you get a finding or an alert or a case, you name it, you have 10 days to disposition it. So that is this a true positive or a false positive? And then previously we gave you 90 days. We're upping it to 120. And the goal is actually just solve it in 120 days, so we don't even have to track it. Delete the data, adopt tokenization, and we'll come to how hard it is to adopt tokenization later. So hopefully in 120 days, you can just sort it out. We don't have to do any further tracking as a company. If you can't solve it in 120 days, then you have to develop a remediation plan that we approve. So the bureaucracy kind of kicks in particular, at the 120-day mark. And again, that used to be 90. We found that we think there's a reasonable population of things that can be fixed in 120 that couldn't be fixed in 90. So in this effort to minimize the bureaucracy, we extended that window slightly. I wish I could tell you that we always hit these SLAs. We do not. That is a constant management challenge to stay on top of folks. But obviously, we'd have no chance at all of hitting them if we hadn't established them. All right, now let's get to the good bits. What do we mean when we talk about addressing readable, sensitive data? So a little bit of an eye chart here. I want to see if everybody's vision is good. And this is to punish people who sat in the back. So we want you to know that next time you should sit in the front. It's just more lively that way. There's a range of things that we can do. So you start at the top. That's what we really want you to do, tokenize your data. But for example, if you have unstructured data, tokenization isn't practical, field level encryption isn't practical. You have to go straight to row 3, object or message level encryption. So we have structured data, the first 2 columns, unstructured data, the right 2 columns. File level encryption is also acceptable when there's, for example, bulk information in transit. But if you're going to go to the default of a file system, a database, or bucket encryption, then that's an exception. We have to approve it and approve the other mitigations you've got in place. And then we're going to track that to the end of time because we don't view that as a satisfactory outcome. And so as technology changes, we're going to look to get out of that as the solution, see if we can avoid that solution. The last 2 are really about transit. And the second to last one is, for example, the credit card industry's protocol for transmitting credit card information, or TLS 1.2 is your only data in transit protection. And again, if you're only using TLS as your data in transit protection, that requires an exception. We're going to track that forever because we don't love that answer. So before we had this, by the way, it was tough for teams because we told them tokenize or die, and then they would have to come back and really just like walk through, here's all the different technical challenges we have, and come to essentially some sort of negotiated agreement. This laid out a much more clear path that in a decision tree that teams could use. So, which tool are we using for scanning? Or sorry, for tokenizing? We really needed an engine that could operate at our speed and our scale. And we have several times looked at the industry to see if there was something out there that we could buy to meet our needs. Each time we've concluded that we're going to stick with a custom tool that we built ourselves. And another reason we did that is because it's super important that adoption is easy. And so we've built a tool in such a way that if you have the architectural features on the left, it's only going to take you under a month to adopt it. And I'm going to go into a little bit more detail on under a month. Here's 3 different case studies from teams that adopted our tokenization engine. So on the far left, this is a new application, Greenfield. I'll read the quotes to you. It took them 2 weeks for a tool that serves 100 million customers. And their answer, I love this quote because this is not the kind of quote I usually get from developers about a security capability. They said, onboarding was fairly easy. I have nothing bad to say. Tokenization is highly resilient and highly available. All right, that's not the kind of comment we usually get about security tools. In the middle, this is a different team. They make 5 million detokenization calls daily, and it took them, again, about 4 weeks for one developer part-time. So one developer part-time over the course of a month. This was fairly early on in the project, and so I think they had to have some back and forth with the tokenization team to make sure they had everything right. So they weren't like racing to get it done. Still took under a month. And then the last one, Again, about a month. Team said the front book was quite straightforward to implement overall. And then they talked about actually some of the challenges with the back book. But again, overall, we're talking about less than one developer for a month. Pretty easy adoption. So we piloted this in 2017. And these are the essentially tokenization or detokenization, so either one counts, operations we do a month. I have no idea why we chose a month other than it turns into numbers that like senior leaders can understand. So arbitrarily, I don't know, we always talk about a month. In 2017, we were using a commercial tool. We were doing about 20 million operations a month. And again, we have to have low latency for this, so performance matters a ton. We're currently up to 160 billion operations a month. And we looked around and we said, all right, let's just benchmark again. And we looked at some of the tools available. And just one example of a leading provider advertised that they would do 2 billion operations a month. And we're doing 160 billion. So the commercial tools just don't seem to be anywhere near where we're operating at the moment. They did not advertise a monthly number. We did the math to get it to a month. So let's talk about our progress at the application level. So we are a large company. We have hundreds or thousands of apps. I'm not going to tell you which. And this is our progress over time in the number of apps that are at destination state. So mostly this means using tokenization. But if you'll remember the table I showed you earlier, if you can't use tokenization, for example, if it's unstructured data, then this could be message level encryption. But you're at one of the approved destination states. So at the end of 2023, we had a pretty large chunk of numbers of applications at destination, a smaller number in flight, and always, always, always in security, there are the exceptions. And so that's really why I wanted to show this chart, was to highlight, we all know that, but we never talk about it. Like mostly when you give a presentation, people are like, we got to 100%. And you're like, really, did you get to 100%? I bet there's some asterisk on that number. And so this is the asterisk, right? Like these are the applications, usually third-party applications, where we couldn't reach the destination state we wanted to reach. Another place where we have exceptions is we're engaging often with a government, maybe a state and local government, maybe a federal or national government that can't accept anything other than maybe either unencrypted information or at best, say, file level encryption. And so often it's actually engaging with an external party that we don't have control over the relationship where we end up in an exception state. All right, so what happens if we have an exception? Well, I think this is relatively normal best practice, but it's also worth talking about. So an application says, I really can't do an approved protection method. They go through a process where a bunch of different groups review their mitigation approach and make sure that we're comfortable with granting them the exception. And so we walk through this is a pretty normal checklist of stuff. Are you at least using database level encryption? Are you at least using TLS to protect in transit? You know, whatever we can get you to. Do you have normal hygiene? Are you patching? All the basic stuff. But you have sensitive data, and so one of the things we want to see is we have lots of different security requirements. Are you at least doing the other security requirements and adding on other mitigations if possible? So, I've made this sound reasonably straightforward, if laborious, but of course it's never straightforward. And so let me talk about some of the challenges we've had along the way. The biggest challenge is, I think at the start of this project, we viewed it as a typical security adoption project. So we all do these projects where we have some new security capability. You start with some denominator, 100 apps, and you're like, all 100 apps need to adopt this capability, and you track the percentage, and the percentage gets to 99%, and then there's one exception, and whatever, you're done. This is not an adoption program. This is a detection and response program. If we'd approached this with a security operations mindset and not an adoption mindset from the start, that would have been more valuable. Because realistically, we're going to be detecting and addressing readable, sensitive data as far as we can see. We may add new data types. We may expand to new countries, and suddenly we have to put in their social security numbers or taxpayer IDs or passport numbers. We may be able to start scanning file types that we weren't able to scan before. We may buy companies where we have to go through this process. Ultimately, if we thought about this more as a tool that would feed the SIM and people would have to respond to it, that would have put us into a sort of operational mindset that would have served us well from the beginning. And so that's the biggest, most strategic lesson we've got. We also have found that, man, free text fields are awful. I had a different adjective than awful, but this is a big public room, so I'll just stick with awful. Free text fields are the worst. So how do we get them? Maybe it's a customer who just, they put in a comment on the web and they give us their social security number because they want us to find their account. Don't ever do that, by the way. Or maybe it's a call center agent who writes down somebody's taxpayer ID, which we train them and train them and train them not to do that, but large scale operation, there's always one person, right? So we've toyed with a lot of solutions there. One of the ones that I think is most promising for our call center agents, where we control the browser, is we're working on a browser plugin that will essentially catch these patterns at time of entry and either immediately redact them or prompt the user to address it. But again, that will only sort out our side of the problem. If a customer is putting this information in, it doesn't address that. So free text fields are just deeply painful. The other thing we found was, that's the creepiest picture I've ever put in a security presentation, just FYI. But we found that we have all these people that we hand the alerts to, and they have to disposition them. And so they have to look at them. They have to investigate. Do I think this is really a taxpayer ID? And to do that, sometimes they were taking the data, copying it into an S3 bucket so they could do some manual analysis of it. Well, if it was sensitive data, we have now just increased our pollution. And so instead, we're developing a clean room approach where we automatically give them a clean room to validate whether this is a true positive or false positive. And then we manage the clean room. We make sure that it gets deleted and wiped and appropriately taken care of. So those are just some of the challenges we've had. It's been a long journey. Obviously, you saw that we started at our pilot stage in 2017. We really kicked out, started moving faster in 2018. And we are now, if I had to intuitively say, I'd say that we're roughly at the 80% level. And now we're going to be going database by database and dumping it. And that's going to be laborious, but it's going to get us that last bit. That is not at all a scientific number, just to reiterate. That is me and my gut. So in short, this has been a lot more work than we thought when we started. And we thought we'd reach a point where we were done, and that's not going to happen. But if I could go back in time with all this knowledge and queue up this decision, should we do it? The answer would be unequivocally yes. This is such a powerful control and mitigant that dramatically reduces the blast radius if you have a breach or an incident. So really a fan of this work. It's been hard, but we stand by it and are super excited about it. So with that, I'd love to take questions.
So for a smaller F5 that doesn't have nearly as much data, customer data points, would you still recommend the developed applications for the tokenization piece, or would the commercial products fit? And if so, which products have you guys looked at that you liked?
Yeah, I'm not going to speak to the specific products in the marketplace. I do think, it should always be open source or purchase before you build your own. You have a compelling reason to build your own and take on that lifetime of maintenance. I think if you are at a smaller scale and you can find a product that meets your latency and scaling needs, you should absolutely go with that product rather than build your own. I think building your own is increasingly not required. But at the time we started, it was. And so I would avoid it if I could.
Good morning. Thank you for the presentation. You didn't explicitly mention it, but after an application detokenizes that sensitive data, it could log it. Do you also scan your logs and look for?
Yeah.
Okay.
So logs go to buckets, and we scan for them in the bucket. So if we find the information from a log, then we also follow it upstream and deal with the logging problem at its source.
So is that a different solution?
Nope.
When you talk to, because they had the right, so to speak, to have access to the real data?
They had the right to have access to the real data. They did not have the right to log it.
Yes.
And so they have to address their logging problem. And then while you're at it, let's make let's validate that they're doing the right things otherwise with the data. So we treat that not as an incident, but as a moment of all right, let's reinvestigate what you're doing here and make sure you're doing the right things.
Thank you.
Mm-hmm.
Hey, perhaps I missed this earlier. How much effort did you have to put in to build your own tokenization engine?
Yeah, I didn't put the numbers in the slide. And it's hard to say because it's now been, obviously, we've been working at this since 2018. Not a trivial amount of effort. So I'm going to spitball developers ranging from 10 to 20 over the course, consistently over the course of those 4 or 5 years. That is a spitball, though, so don't take that to the bank.
No, I think that's good enough so people can get a sense of should they go commercial or should they do what you did.
Yeah.
Thanks.
You bet. Thank you.
Yeah, thank you for your presentation. It's very enlightening. The data, you identify PII in your S3 bucket, and then you trace it upstream to the source, then you remediate it there, you tokenize it, and then it goes back down to the S3 bucket. How do you get the original data that was recorded, PII, to the S3 bucket? How do you get rid of that? Because it's a permanent record of that data.
I'm sorry, can you run that past me again? I apologize.
Like, data came from the source, it went to your S3 bucket, it was your PII was written out there, social security number or whatever, and then you mitigate the source, and then it gets rewritten to the S3 bucket. Is it overwriting the S3 bucket, or is the original unencrypted PII still there?
Yeah, so you have to address it both places. We got to, if it lands in the data lake, we have to get it out of the lake, and we also have to go upstream and stop that source from producing new data. So we do have to do both. There are some cases, not the case you just described, but we store historical data for a period of time, and we are not going back into the archives of essentially backup data and reviewing it there. But we are looking at it if you bring data out of backup. So if you're restoring from a backup, we scan you then. But for backups, we are just essentially planning to age it out. If it's backups that are again, not in actual usage.
Okay, thanks.
So there are different approaches to tokenizations vendors choose. Is there a particular one you choose, like stateless versus stateful, and reasons for the choice?
We have tried both over time. I think, and we've also tried more centralized engines and engines that are sort of per application, like instances of per application. I think the right answer at the moment is stateless with a local instance for your application. One of the other things I should highlight is so much opportunity for logging and detection at the tokenization engine, right? Look for anomalies in the scale of detokenization. And you need to be logging which tokenization and detokenization calls happen in case you do have an adversary that lives in your environment for a while. You need to be able to go and figure out what could they have seen. So a lot of important capabilities there.
Just a follow-up, you mentioned applications have to change. You have plenty of legacy applications, clearly calling APIs, and which is not part of the original design. Didn't that take a lot of time and effort in that respect?
Yeah, this goes back to the cloud migration for us, because during that migration, we did not lift and shift. As much as possible, we modernized applications, And modernizing is also a nuanced term. Like there's a lot of different, there's a big scale of modernization. But we did a reasonable job of that. And so while there are some applications where this has been tougher, for the most part, our applications were modern-ish by the time they had to do this. And that helped enormously. So that's exactly why I started with that cloud migration.
Thank you.
I don't know if you're willing to share this or not, but did you say whether you're using like an FPE approach, like an encryption approach, or substitution approach?
Yeah, I don't want to go into those details. I apologize. there was a lot of wrestling with legal to get here. Go ahead.
Just curious if you had any issues with referential integrity. Like were cases where you could or couldn't detokenize, and if so, if you had any lessons learned for us around that?
It's a fantastic question. I don't know the answer to that. I would any large project of this nature, I would actually assume, but that has never come up. And so if it has, it's been a tactical enough problem that we were just able to sort it out.
Thanks.
That's a great question, and now I'm going to go back and ask it.
So I'm trying to understand the practical use, like say in a Word document, Excel file, you're scanning them, you find the social security number, and you would replace it with a token if it's justifiable to be in there?
So that would be an unstructured data.
Right, and then say the owner needs to use it, how do they get access to the data? Are they looking it up separately to try to make sense of it, or how does that work?
So we don't want you to have social security. So first of all, if it's in a Word file, just don't do that. I really can't think of a use case that would be acceptable. I guess there's the automated generation of certain letters, but we wouldn't put a social security, I just can't see it. It's a big world. Maybe there is some case out there, but I can't see it. I think data or spreadsheets are a more likely problem, right? You try to kill all the spreadsheets in your world, but you're never going to succeed in it. There's always going to be some spreadsheet use cases. So if we get ahead on a spreadsheet, essentially, a user gets a notice to deal with it, and then they can make different choices for how to deal with it. I do think that we have exceptions for certain spreadsheets out there, and that's one of our areas where we really have to continue to do work. But I agree that that's going to be one of the messiest spaces. That, by the way, falls more into our. Falls more is the wrong answer. It's sort of halfway between our data loss prevention program and this program. Because we are also sort of scanning and classifying files in our data loss prevention program and alerting people on sensitive data that they shouldn't have on those files. And so it's interesting that this is where these programs sort of overlap, and you have to build some joins between the two programs. All right, well, it looks like I've exhausted the questions. I super appreciate everybody attending. Thank you very much.